Well, good afternoon. I'd like to talk to you this afternoon about an exciting and interesting new concept in the region to manage the waste that all of us produce in the region here. We all have a part in this. So we're looking towards having an integrated, collaborative, and sustainable waste to resource community in the region. If we can do this, we will provide significant sustainable benefits to stakeholders and residents in the region, and we'll also make a sizable positive contribution to global climate change issues that we all face currently. So every day in this region, there's hundreds of tons of waste placed in the landfills throughout the region. This is a picture of our new landfill just south of Fort McMurray. It's been in operation for about a year now. There's absolutely nothing good in this picture whatsoever, except perhaps that we're sustaining the raven and gull populations in the background here. So there's all kinds of material in here that shouldn't be in here. There's a couch, there's a wood pallet, there's all kinds of plastic bottles. Kitchen waste is actually very valuable. All of this stuff is in the landfill. So in this region, does anybody know that we actually generate more waste per person than anywhere else in the province? And that the province of Alberta has a higher average than anywhere else in the country? So why is that in this region? Well, there's a couple reasons. The first one is growth in the region. When an area is in growth mode, there's a lot of construction and renovation going on. That generates a lot of garbage. The second reason is economic prosperity. When people have money in their pocket, they buy more stuff. And if you buy more stuff, you make more garbage. So those are a couple of the things that are contributing to why we have so much waste in the region. So back to the landfill here. This is cell 1. This is cell number 1 of 56 cells that we're planning out on our landfill site. We have 500 acres, and we think that there's much better uses for this land than as a landfill. 500 acres could house 6,000 people in Fort McMurray if we were to turn this into a residential development instead. So there's much better use for this land, whether it's parks or residences or business opportunities. So that 500 acres and 56 cells will last us for the next 80 years if we keep landfilling the way we are. And that includes using some new technologies such as composting and recycling. But when we look at this, we say, well, what's the big deal? We're good, we got the land, we can keep going. Other communities are not nearly as fortunate. Many communities have trouble finding space for landfills now. So again, what's the big deal? Well, with landfills, it's not only about the land they take up, they're significant contributors to climate change as well. So all this garbage in the landfill, when you place it there and bury it, over time it degrades and it forms methane gas. And methane gas is 20 times worse for climate change than carbon dioxide, which is what comes out of the tailpipes of our cars or the vents on our furnaces. As well, as I said, we do try to do some recycling here, but if you think about it, what are we accomplishing? We collect some plastics and paper and cardboard and we send them to Edmonton. But we're incurring carbon emissions all the way down the highway for 5 hours to get it there. So we're actually significantly lessening the positive effect of the things we're trying to do by shipping it out. So we started thinking there must be better ways to manage these environmental issues. And we sat down and put our heads around it. We do believe there is better ways. But not, when we thought about it, we thought this is a much better look to our landfill than the last picture. We could have greenhouses making plants, produce, tomatoes, cucumbers. We can have plastic lumber, and we can make concrete out of aggregate and ash on the site. But what we realized out of this isn't just about environmental benefits. We can also see social and economic benefits by doing this as well. So the opportunity is right now. There's a number of advantages the community does have that other communities don't necessarily have in such scale, but we have a strong economy in the region. We have significant industry and commercial businesses in the region for partnerships. The community is also very young in its life cycle. We have an opportunity now that many older communities don't, where they're established in their systems and their infrastructure. But as we're planning and building for the next 50, 60, 100 years, we can make changes now that other communities don't have the opportunity to. So when we started thinking about this, we thought, let's stop landfilling in the region entirely. And when we came up with this goal, we quickly realized that we're not going to be able to do this by ourselves. We're going to need partners in this. So when we started talking to partners, we came up with where we're going now is we're going to build world-class waste-to-energy facilities. We're going to have an integrated center of excellence with the local college, and so they can undertake research and development to make our projects even better, and then they can share this knowledge with others as well. And then where the landfill cells were going to be, we want to put an eco-industrial park in. And the businesses there will be synergistic with the operations that we still have and with each other. So everything becomes integrated and nothing is wasted. So how are we going to do this? For the residents and our customers, industrial, commercial, residential, nothing really changes. You keep making garbage. We're not going to stop making garbage. That's the reality of it. If anything, the process will become easier for customers. The real change begins at the logistics stage. So when waste comes to the landfill now, we have the opportunity that we're going to start taking raw materials out that we never have before, like gypsum. And then we're going to use those, pull them out, and we're going to remanufacture and make new local product lines instead of sending everything down the highway to be made into a new product somewhere else. From there, waste that's still left over after we've extracted what we can will go into a waste energy process. In this process, we'll make electricity and heat out of this from the portion of the waste that has energy potential. And when we're finished that stage, we'll have a residual material we can still use, and we'll actually be able to use all the residual material at the end in more new product lines out at the landfill. So this is the energy conversion part of the process. This is a conceptual drawing of our first phase, which we're going to have up and running this fall. And it involves a gasifier and biodiesel plant and low-speed diesel generator. So the waste is put in the orange hoppers here. That's the gasifier. And it's converted to energy and makes what we call synthetic gas. And synthetic gas can be used in conventional heating applications, like boilers or water tank heaters. Or we can combine it with biodiesel and make electricity from it. And the biodiesel plant here is the blue tanks. So the biodiesel and the synthetic gas are combined into the yellow motor there and makes electricity. We're actually very fortunate. Biodiesel is made from waste cooking oil. And we're very fortunate to have a pile of waste cooking oil in the region with the booming hospitality sector and all the camps that are housing and feeding the workers. Right now, waste cooking oil is hauled down the highway hundreds of kilometers and it's made into soap or biodiesel. So to convert it now, again, you have all those carbon emissions and costs to transport it those long distances. And if we wanted to use biodiesel in the region, we have to bring it back again. So we have more money and more carbon emissions. So it really doesn't make any sense not to make our own biodiesel here. And so then in the first phase of the project, we're going to take the electricity and the heat, and we're going to put that into a greenhouse. And we're going to be making cucumbers and tomatoes and things like that derived from the waste heat energy. What's neat about the system is it's also a closed system, so we will take the exhausts off the heat transfer devices and we'll pipe that into the greenhouse, so that's your carbon dioxides. And by injecting it near the plants at the base, you can actually increase their productivity 30% or so, and you sequester the carbon that you're trying to keep out of the environment. So we're calling this SWAP, and this stands for Solid Waste Alternative Process. And it's pretty catchy for a group of engineers to come up with this, but it's actually what we're doing. We're swapping waste and making it into energy and products. So, and this is actual equipment we'll be using. The picture on your left is a low-temperature gasifier. In the middle is a portion of a biodiesel plant. And on the right-hand side is a low-speed generator. So you couple these all together and make these products. But what's really neat, looking at the photos, is they're all relatively portable. All of this equipment will fit on the back of tractor trailers. And so what we can do with this is we don't have to build big fixed plant sites with overcapacity. We can build them in modular or in parallel, and we can scale up and scale down on sites as there's new alternative uses for them, or as there's new material cycles, or in the cases some waste will fluctuate during plant turnarounds, or an old site will be running out of waste, and so we can take units away from there and move them to a new site. So we don't have to build a lot of fixed plants and spend a lot of extra money, and by having plug-and-play units that can deal with any waste stream, we save on steel, we save on natural resource depletion, we save on energy, and we cut back on greenhouse gas emissions, as opposed, I said, to building big fixed overcapacity plants. So these are the outputs of the SWAP process. And this is actually the inside of one of those gasifiers. So what's really unique about what we're doing with this process is it's low temperature gasification. Conventional thinking on gasification right now is high temperature. So all your tin and your glass, all your metals, they come out as a big molten blob, and it turns into solid when it cools under conventional technology. And you can't do anything with it. It's a big piece of blob. So you still need a landfill. But by going with the low temperature technology here, which is this is a picture of, you can see in there that we still have, you can see the glasses, glass jars, you can see the tin cans, you can see the metals. We can take that all out and make that into product now. So what this actually does is it's going to increase our recycling in the community. We'll be recycling at a scale like we never have before. So a good example is a gum wrapper that we've all seen before. And you put that in the gasifier and the wax paper is converted to energy and the foil comes out the back end. So there's never been recycling on this type of scale before at this level of detail. The jam jar is an interesting picture. It shows how easy this is going to be for our customers. Right now, if you want to recycle your glass jar, as many of you know, you got to wash it out and you got to put it in a separate container when it gets picked up on curbside collection, or you got to drive it to the recycling depot yourself. Now all you have to do is when you're finished with the jar, just throw it in the garbage. You don't have to clean it out anymore. When it goes in the gasifier, the jam is converted to energy and the label's converted to energy and the glass jar comes out the back end. So it's a lot easier, a lot more simplified. The electrical wire here is interesting. There's all kinds of new waste streams we're coming up with, but you can take this electrical wire and you can either strip the plastic off before the swap process and recycle the plastic and the copper, or you can put it into the gasifier and convert the plastic to energy and then capture the copper on the back end. And that's still a good process because we get energy value out of it, and the emissions from it are routed to the greenhouse to increase productivity and sequester the carbon. So this is a slide that did it all for me when I was trying to figure out why would we do this, and this simplified it all for me. So right now I think, at this time of year in Fort McMurray, our produce isn't always the best. I find it kind of flavorless myself and sometimes on the verge of expiry. So it costs a lot to get it here too. We all know how much we pay in the stores. But think about where it's coming from. It's been transported all that way and it's been produced with conventional energy sources as well. So if we were to make tomatoes in greenhouses here in Fort McMurray, we believe we can make an organic product that's of better quality. We can make it cheaper and it has no carbon footprint. So we did some estimates on carbon footprints of imported tomatoes, and it's about 83 grams of carbon dioxide equivalent per tomato. If we manufacture or produce them locally here, it's about 0.5 gram. So I just wanted to quickly recap where we were, where we are, and so I can talk a little bit more about where we're going with this. So historically, industry, communities, commercial institutions all kind of did their own thing with waste. And some of them recycle a bit, and some of them compost a bit, some of them do nothing. But basically, they were inefficient, and it was all ending up at the landfill, which causes greenhouse gases, as we've talked about. So now, where we are, we're at an emergent ecosystem, and so we started out here, and we figured out, well, we're going to pull stuff out at the beginning and make new products, and then we're going to make energy, and then with whatever is left, we're going to make more products. And we were pretty proud of ourselves. This is pretty cutting edge. But when we started talking to our stakeholders, this is what happened next. So we're into a collaborative ecosystem now, and the opportunity here is unprecedented. So, while we're going to continue with what we're doing, we're into big concepts now like district energy and communities from green energy. So new developments like Parson, the downtown revitalization. We're into effluent recycling discussions with the oil sands industry. We're looking at purple water systems. So that's in wash bays and stuff like that. Why, you put a lot of energy and chemical into potable water. Why do we wash our trucks with potable water? So we can have a lot of savings there in energy and chemical costs. So there's all kinds of neat things we're looking at. We're even looking at waste energy, low-grade waste heat energy pipelines from the plants in the region, the industrial plants, such that we can bring all this heat into the urban service area to use in heating in your home. So the opportunity here is really unbounded. So this is a picture of a tailings pond reclamation project. And you never see this one in the media, but anyways. So this is an example of actually collaboration that's starting between the companies within the oil sands. And with this project, actually, we're taking this cooperation to the next level. This is about getting that type of collaboration and integration and sustainability practices between non-traditional partners. Whoever would ever thought that industry and government and educational institutions could all work together the way we are on this project. So that's what's been really neat, and this is, some of our partners' views on what we're trying to do here, but the important thing is about how all aligned they are. They all say the same thing and they all want the same thing. So why can't we do that all the time? So the real learning about this is the technology's fun and we're having fun playing with it, but the real learning in this for us has been about the collaboration. And we couldn't do this, couldn't even contemplate the project where it's at right now if we didn't have the collaboration of all the partners in this. Thanks for listening to my ideas today.